Hi, in this session we'll discuss about solver. Now solver is used when you have a value in mind for your dependent variable or you want to maximize the dependent value or minimize it and you want to change the values of the input variables to achieve that value. So basically it's exactly opposite of what if analysis. In the what if analysis, we had seen the change or the impact of changes to the input variable on the dependent variable. So this is exactly the opposite. So over here, you've got some input variables and you've got a dependent variable or an objective in mind, and then you go about changing the values. It's a sort of an optimization tool, but before jumping onto it and how it works, there's a prerequisite. So go to file, go to options. Now click on add-ins. Now in the add-ins, analysis toolpack should be added in. If not, then just click on it and click on OK. So then you'll have this analyze toolbar appearing in the data group. Now click on solver. So this is how it looks like. So set objective, whether you want to maximize a particular dependent variable, you want to minimize it, or you want to keep it at a particular value. Then by changing which variables. So over here you will specify the input variables or the location of the input variables. Then over here you will add the different constraints, and we'll take this example over here so that this all is easily understandable. So let's look at it. So over here I've got a company and the company produces three products A, B and C. So right now the company is producing 50 products of each A, B and C. So the total units it is producing is around 150. Over here we've got price per unit. So for A, one unit will fetch 250, for B 150 and for C 350. And we've got the cost per unit also, 90 pence, 20 pence and $1.70. Now just looking at it, you've got the total profit. Again, let me just show the formulas over here. So the total profit is basically based on the number of units sold, and then you just subtract the price and the cost and then just multiply it with the number of units. So basically the profit into the number of units. This formula over here, this is just the sum or the total number of units being produced right now. And this is the overall profit. So profit from product A, product B and product C. Now let's just remove this. Okay. So now our objective over here is to maximize this profit. Now there are some limitations over here. So one of the limitations is that the overall units which can be produced in a given month cannot be more than 450. Now for these individual products also we've got certain limitations. So we cannot produce more than 250 units of product A, more than 400 units of product B and more than 100 units of product C. So let's see how solver will work. Set objective. We want to maximize overall profit. We want to maximize it by changing variables. Now the variables which will change over here is these units which are being produced, because this is the only thing which we can change. The price and the cost, they will remain the same. So it is this production of these units which we want to optimize. Now we'll add the constraints. So add. Now the first constraint will be this, that is the number of units for product A should be less than equal to this. Add. For product B, this should be less than equal to 400. Add. For product C, this should be less than equal to 100. Add. The overall units should be less than equal to 450. So we've got these four constraints over here, and let this remain as GRG nonlinear. We'll click on solve. So we've got a prompt that solver has found a solution. Now one thing to note over here is that there might be times when solver may not be able to find the solution. So then you'll just have to change around some constraints or probably your objective to get to a desirable result. Let's click on OK. So as you can see, now your number of units has changed and your profit has also increased to $710 from $235. So now what Excel is saying is that we can produce 250 units of product A, but only 100 units of product B and 100 units of product C. And when we optimize all of them, we'll end up with 450 units in total because that was the limitation, and we'll have a profit of $710. Let's look at another example of solver. Now, this is something which the operations teams in banks usually use. In the fraud or anti-money laundering environment, there are always some strategies to identify frauds. Now, these strategies then throw up alerts, and each of these alerts has some scores. Over here, what we can see in this table is that there are in total 325 alerts being generated by strategy 1, 398 by strategy 2, and just 98 by strategy 3. So this is for score greater than equal to 1. So this will also include the count of people having scored 2, 3, 4, 5, and so on. Similarly, 398 is for all the people having a score greater than equal to 1. So it will also include alerts where the scores were greater than 2, 3, 4, 5, 6. As we keep on moving to the left side, the number of alerts keep on reducing. So for a score of greater than equal to 9, we just have 125 people. For a score of greater than 10, we just have 100 people. So now there is always a limitation around the number of cases which can be worked by an operations team because they've got their own deadlines also, and then they've got their own resources also. They cannot investigate each and every alert which gets generated. So currently these strategies have a set score. So for strategy 1, we are right now having 125 alerts. So basically any alert with a score of greater than equal to 9, we are considering for strategy 1. For strategy 2, we've got 128. So any alert with a score of greater than equal to 8, we are considering that. And for strategy 3, we've got 51. So any alert with a score of greater than equal to 6, which is being triggered by strategy 3, we are considering it. So in total, we've got 304 alerts right now, but we want to optimize this to 400. So we want to increase the number of alerts from 304 to 400. So by 96. There are some more restrictions. One is that the alerts which are being triggered by strategy 1 should be more than by strategy 2, and alerts being triggered by strategy 1 should be twice that being triggered by strategy 3. Now, this may be because the bank feels that strategy 1 is more important or it identifies more risky cases. Then there are some more constraints that for strategy 1, the number of alerts should not exceed 170. For strategy 2, the number of alerts should not exceed 180. And for strategy 3, the number of alerts should not be more than 90. So let's just copy this first so that we can compare it. So let's go to solver. So our objective is that this particular sum should be less than or equal to 400 by changing values, these values. Now we'll add the constraints now. So the first constraint is this should be less than equal to 170, add this should be less than equal to 180, add this should be less than 90, add, then this should be greater than or equal to this, add, and this should be greater than equal to 2 times this. Click on OK. So now I've got these constraints added. Now let's click on solve. So as you can see now that Excel has given you a solution. So what it is saying is that we can maximize strategy 1 to 170. For strategy 2, we can again maximize it to 170, and for strategy 3, we can keep it at 60 only. So in terms of scores, if you look at it now, so for 170, it would lie somewhere between 7 and 8. For 170 for strategy 2, it would lie somewhere between 6 and 7. And for strategy 3, 60, it would lie somewhere between 4 and 5. So this is how the operations teams in the banks optimize their resources and choose the score thresholds accordingly. After this video, we've got some exercises for you to work upon. Thank you.